Hi everyone, Queeveen here from the comfort of my kitchen. We have been looking a lot at the planets recently, and a few videos ago when I spoke about the parade of planets, we followed some of the planets through the constellations that they're going to be in over the next couple of months. Of course, for planets that are closer to the Sun, like Venus and Mercury, they change what constellation they're in front of quite quickly, whereas for slower moving planets like Jupiter and Saturn, they can remain in the same constellation often for the entire year, only moving from one constellation to the next over longer timescales. Mars is further from the Sun than the Earth, and as such, it does have a longer year. However, its year is only twice the length of the Earth's. Not entirely sure why my horizon was coming up. The year on Mars is only twice as long as the Earth's, and as such, it does noticeably move across the sky on smaller timescales. There will be a little bit of wobbling from side to side here because we are watching Mars go above and below the horizon. But you can see, despite this side to side wobbling, that Mars is moving into Gemini there, and then out of Gemini and into the next constellation over the course of time. I am going to try to yeah, if I go day by day, it'll be a little bit easier. So let's pull back. We'll see less wobbling. There we go, back into early January when Mars was sort of behind Gemini. So we'll zoom in here and take a closer look and go day by day. So we can see Mars here moving into Gemini, stopping, turning back, leaving Gemini again, staying in retrograde motion all the way into Leo here, until eventually it ends up going behind the Sun. So this is the Earth essentially moving away from Mars, overtaking Mars. Mars is on the far side of the Sun. And then we start to catch up to Mars again. So this is going to be next year. We're going to catch up to Mars. It'll stop. It will appear to move forward, and then we'll move past it. It will appear to move back. This happens all of the time. This is the retrograde motion of Mars, this little loop that it does. So I'm going to bring up the orbits of the planet. There it goes, doing its full loop. We'll get back to this year. We're after going all the way forward to 2026, because of course this does happen every year. We can see moving backwards in time. There's Mars on the far side of the Sun from us, almost directly in line, but you may have noticed Mars appeared to be a little under the Sun there, and that's due to differences in our inclination with respect to the ecliptic and the Sun's equator. So coming back, there we go, and there's Mars back in Gemini. That's the second time. There we go. There's its first entrance into Gemini for January. So let's bring up the orbits to see if the little loop is actually traced out. I do not believe it is. So that's unfortunate. Seeing the little loop makes these things, seeing the little loop makes these things a lot easier to see. The same thing that happened in my last video has happened again, except forward this time, all the way forward to, is it, it's only 99,999. I thought it was 999,999. Not as far as I thought, but, you know, what's a factor of 10 between friends. So there we go, 2025, we are indeed in January, and I'll just drop a 6 there after that. Perfect. So we can see here Mars is moving in the direction that we'd sort of expect a planet to move across the sky, because it's following the path of the stars. It's actually moving faster than the stars across the sky, but we expect night by night that a star at a given time will appear further and further to the west as we move around the Sun. And that's exactly what's happening with Mars here. Even in the later part, all through January, the later part of January into February, we're seeing Mars a little further west at a given time every single night. The normal prograde motion of a planet. Here, I guess it's the 21st or thereabouts, 25th maybe of February. This is where Mars turns around, and from the 25th of February all the way back, it's going against the motion of the stars. Now, unfortunately, it's not doing it quite fast enough. As we continue to move, we will get around to the opposite side of the Sun. All we need to remember here really is that Mars is also orbiting around the Sun. It's orbiting, if I can demonstrate this way. So Mars is here, and it is orbiting around the Sun. The thing is, we're orbiting faster. There we go, all the way forward to the future again. We're orbiting so much faster that we eventually catch up to Mars, and that's when it appears to move backwards. We lap Mars, to use the terminology that's used in athletics anyway. I don't know if we actually use it in astronomy for these kinds of things, but to lap something, basically we've made a complete orbit around the sun and overtaken Mars while it continues to make its complete orbit around the sun. All right, so we've gone back here to 997. All of the constellations are out of place, but we'll move back to the end of that retrograde loop. There we go. So moving forward in time, we'll see Mars slow down, appear to change direction again, and that's us moving past Mars, catching up to it, and then moving ahead of it in space. I'll bring us way, way back to today again. The retrograde motion of Mars at opposition, it's a very interesting thing to see, and I find that it is a fun one to pull out if people are talking about astrology, simply because the retrograde motion of some planets, like Venus and Mercury, is considered such a big deal, whereas the retrograde motion of these other objects, like Mars, like Jupiter, like Saturn, it's not considered as important, despite the fact that it is a very similar phenomenon and an illusory phenomenon. Of course, these objects aren't actually moving, you know, they're not turning around, moving backwards, and then changing their mind and moving forwards again. It's all an illusion caused by the relative positions and relative motions of the Earth and these planets. Of course, we are all moving around the sun. And this is something that you can observe yourself. You don't have to take my word for it. You can go out, take photographs, and see Mars change in position with respect to the stars in this way. Mars has seasons. So I was planning to take a closer look at Mars because of the retrograde motion at opposition. It's something that I've mentioned before, and it is an interesting phenomenon that we see on Mars. But a subscriber, a commenter, the same commenter actually who gave me the last idea that I decided to steal with credit. Of course, this idea was given to me by a commenter. If you check the comments of my YouTube videos, you'll see who they are. They can make themselves known if they so wish. But it is a good idea. Now, I'm going to get rid of the atmosphere. I'll keep the ground. I might change the ground to something a little more appropriate. We've at least got the moon. There's Mars. Great. So here we go. There's the rover. We're a rover here, apparently, which is nice. Not sure which one, but yeah, find it hard to tell just by looking at the solar panels. So here we are on Mars. There's the sun, and I will bring up our ecliptic. Mars has a tilt very similar to the Earth. So it goes through seasons in a similar way to the Earth. The seasons on Mars are created. I'm not getting the ecliptic. Maybe it only shows the ecliptic from the Earth, which would be strange. But maybe the ecliptic grid. The ecliptic grid is coming up, and it's a little bit messy, but it will do. So there's the sun pretty much on the ecliptic, Saturn, Venus, etc. So what we're going to do is we'll come back. We'll face south on Mars. We're in the northern hemisphere of Mars, so we're here looking south. So if we move forward here, we can see the sun climbing, getting higher in the sky as we come through to Martian summer. There's Mercury and Venus. We can see them looping around the sun there. And there's the Earth about to go, I believe, is that between us and the sun? I'm not sure. It looks pretty illuminated, so probably not. It's probably on the far side of the sun from Mars. And here we go, Martian winter. Nice and low. And that's a very observable difference. We can see there the sun moving through its lowest and then climbing higher in the sky, just like it does for the Earth. Of course, the seasonal variation, there is a lot of other factors going on here on Earth. Mars certainly doesn't have a monsoon season because there's no water. But roughly speaking, we've got the northern hemisphere being warmer while it's tilted towards the sun, and then the southern hemisphere being warmer while the southern hemisphere is tilted towards the sun, as it would be roughly here. So Mars goes through seasons just like the Earth, and we can see the sun going up and down. Despite the fact that its year is twice as long, so these seasons last twice as long, they do operate under... Oh yeah, there's the moons. It's the moons that are flashing by really quickly there. It does operate under the same principles as our year here on Earth. I removed the atmosphere simply because it makes all of this easier to see. Of course, Mars does have an atmosphere. It is a thin atmosphere of carbon dioxide, but it is sufficient based on all of the images I've seen. Obviously, I haven't gone to Mars to check myself. But based on all of the images that I've seen, the motion, or based on all the images that I've seen, the carbon dioxide in the atmosphere of Mars is sufficient for some sort of scattering to take hold. I don't know if it's Rayleigh scattering, which operates here on Earth, but Mars's sky has a color during the day, and the light of the sun being scattered through that colored atmosphere blocks out the stars. So if you were actually on Mars, you wouldn't be able to see the sky like this, unlike the moon, which actually doesn't have an atmosphere, and this would be visible. What counts as an atmosphere varies. Some planets have an exosphere or a transient atmosphere, where at nighttime or when they're further from the sun, the atmosphere freezes, whereas during the day or when they're closer to the sun, not saying they're the same thing, but perihelion or daytime, whichever, is sufficient to raise the temperature enough to cause gases that sublimed onto the surface to evaporate back into the atmosphere. That's something that happens. It sort of happens on Mars as well with winter and summer, but that is something I will get into in a future video where we look specifically at Mars. So if you saw my last video where I discussed these objects, that's handy, Makemake in particular, and then some of the other trans-Neptunian objects, candidate dwarf planets, de facto dwarf planets, whichever, however you want to talk about it, I mentioned that I will be looking at the major planets like Mars, like Mercury, like Venus in more detail, talking about their specific features in the future. If you don't want to wait, for the future video where I take a closer look at Mars and its individual features, all you need to do, that's the Earth Observer, I want to go to the Earth. All you need to do is go back on my channel, because I have discussed, wrong grid. I have discussed the planets of our solar system, the non-dwarf planets, the actual planets of our solar system, in several videos in the past. You'll just have to go back on my channel to find them. But I will be doing more of those in the future. They will be covering slightly different content, so it might be nice to watch both of them. You know, you can watch the videos about Mercury and Venus and Mars that I put out in the past, and look forward to the future videos that I'm going to put out as well. So that brings us, well, way into summertime, but at least that brings us to the end of the video. So I hope that you did enjoy it. If you did, please do like it. You can also subscribe to this YouTube channel to see more of my videos in the future, and you can read some of this information on my website, queeveenscontent.ie. So thank you for watching, and hopefully I'll see you back here next time.